Welcome to PDM's presentation on laser scanning for infrastructure. Laser scanning for the capture of plant and equipment is efficient, safe and cost-effective. Only one person is required for the scanning of structures. No confined space entry is required, neither is gas detection equipment. After calibration of the equipment, scanning will commence, which only ever generally takes a few minutes. Processing of the captured data results in a 3D point cloud model being created that can be analysed for defects and deformations. Black and white high definition imagery is also captured, which can also be used when assessing structures for condition. The process for condition assessment involves creating a model of the design structure and comparing to the 3D point cloud model. Comparison reports summarizing percentage deviations from design and cross-section analysis provide far greater condition information of assets than from any other method. What can be seen here is the colorization of the differences. As you can see, wherever I click on the model, it's telling me how many meters of difference between the design model and the 3D point cloud. The dark blue areas that can be seen here are within the vicinity of 20 millimeters of difference. Cross-sectional analysis visually shows you the difference between the point cloud model and the outer ring there, which is the design model. The printed report can be customized to meet the client's needs. The maximum and minimum critical deviations from design can be set, as well as the nominal deviations, or in simple terms, what would constitute the asset to be in either good or poor condition. This report shows you the percentage of data that falls within a certain zone. You can see here that 14.5% of the data captured falls between plus or minus 5 millimeters. And here 59% of the data falls between 5 and 10 millimeters, and 8% falls between 10 to 15 millimeters. Images of the colorization of the differences can also be seen in the report. cross-sectional analysis in the report are very similar to what you've already seen before, with percentage deviations being reported. What I'm going to do now is run you through a pump station scan that we undertook, looking for deviations in the walls. Several scans needed to be undertaken to build a full picture of the pump station. Black and white imagery was also captured. This black and white imagery here is of the wet well. This black and white imagery is of the dry well, and as you can see it is of quite high definition and quality. From these images too, in the software that we have, we're able to take measurements. The measurement from wall to wall here is 3.51 metres. So what we decided to look at was look at the alignment and see if there was any deviations from the dry well, which would be believed to have no issues, and taking that line out and putting it across onto the wet well. This is the northern faces, two faces of the wet and dry. As you can see in this analysis, the green area on the left hand side is the dry well, which is all fairly uniform, and then we look at the wet well, which is the right hand side, that's got the dark blue through the light blue into the green in the corner, is showing that there is a minus deviation in the bottom left in the dark blue, and a green and yellow, which is a plus deviation, in the top right hand corner. I then went over to the wall opposite to do the same analysis, and what I found there is the dry well, which has the majority of the green in it, is all fairly uniform, and I found the opposite on the other side being a plus deviation in the bottom left corner going to a dark blue in the top right hand corner. So this to me indicated that there was something wrong with the alignments. So I then went back and turned the model over so that I could visually have a look to see if I could see the differences. When I did this, I could see that there was a misalignment. This means now that I wouldn't be able to use this as a form of analysis to find out if the wet well has a problem. So now what I decided to do was purely analyse the wall of the wet well, and that's both sides. This is the analysis of the wet well. Mostly the wall is uniform, apart from that yellow area and blue area down the bottom. And on the wall opposite, same. When I looked at the reports, I found that 78% of all the data was within plus or minus 5 millimeters, and only 14% between 5 to 10, and no further major deviations thereon. I identified that blue area earlier. I decided to go back and look at the imagery to see if I could determine what it is, because it didn't seem correct. When I looked in the imagery, I could see that there was a pipe in that corner that the scanner would have picked up. So that would then say to me that that wall is all uniform and okay, with no major defects. When I looked on the wall on the other side, 70% or thereabouts were in plus or minus 5 mil, 9% in 5 to 20 mil. Looking at the colorization, I could see a blue area in the middle, also went back into the imagery to have a look and found that there was no major reasons for concern. I would now, in my report, say that this wall has no major issues. Okay, benefits of laser scanning for inspections and reverse engineering. Copies of products and components for which there are no as-constructed plans or CAD data available can be created. Condition assessments, precise 3D documentation and dimensional inspections, comparisons, analysis to designs, asset management or R&M planning. Models can be compared over time and works can be planned on a degradation rate. And there's also study opportunities. Quantifying. Accurate quantities of material can be calculated for repairs and maintenance, and when completed can be verified. And there's the safety element as well, where there's an elimination of confined space entry. PDM provide professional services in LiDAR scanning, project management, engineering management, construction management, facilities and asset management, workplace health and safety management. PDM have memberships on many panels, the Townsville City Council panels for project management and engineering services, and local buy. PDM also have many accreditations, and I would like to thank you for taking the time to listen to this presentation.